All right, here we're looking at section 10.3, and in this section we only have one learning target. So today we're going to be using chords of circles to find lengths of arc measures. So remember before we were looking at central angles where the angle was in the circle, so now we're going to be using chords to help us find some arc measures. So first we want to look at a couple of theorems. So our first theorem we're going to look at is the congruent corresponding chords theorem. So what that tells me that if I have either in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So that tells me if I know the lengths of the chords are the same, then I know that the arc length of my circles is the same as well. That's what that theorem tells me. So this second theorem is the perpendicular chord bisector theorem. So here we're also dealing with the diameter. And remember that the diameter is just a special chord. So if I have this diameter, and it's perpendicular to another chord, right, so it makes that right angle, then that diameter bisects, so it means cuts in half both the chord and the arc. So if I have the diameter that's at a right angle to a chord, that chord is cut in half, and the arc that the chord creates is also cut in half. So now here's our third theorem, is that perpendicular chord bisector converse. So if one chord of a circle is perpendicular bisector of another chord, then the first chord is a diameter. So I see here that this chord is cut in half and the two chords are perpendicular, then that tells me that QS or SQ is a diameter of a circle. So that can give me some other information. So here we go. In this diagram, circle P is congruent to circle Q. So I'm given the information that I'm dealing with congruent circles. So FG is the same length as JK, right, as denoted by those lines. And I'm also told that my radius is the same length. That tells me that I have congruent circles. So I know the measure of arc JK is 80 degrees. So find the measure of FG. So since I know that my circles are congruent, and I know that my chord lengths are congruent, as I'm told that all up here, I know that using my congruent corresponding chords theorem, they're the same measure. So I know the arc FG is going to be 80 degrees as well. And I know that because my circles are congruent and my chord lengths are congruent. So now here's our next example. So here I'm supposed to find HK. Right? And HK is the entire chord that's cut here. So the first thing I notice is that I have a diameter here, JL, and it does bisect this. And I know that it's bisected because I have a perpendicular lines here. So it's at a 90-degree angle. So I know that the measure of JH, this arc, is the same as JK. And I know that NK is the same as HN. Okay? So that's some information that I know first. So I know that NK is 7, so that also tells me that HN is also 7, so I know the entire length here is going to be 14. So now let's look at B. Find the measure of arc HK. So here's HK as the entire thing. Well, I know these two pieces are equal since this is a diameter and it's a right angle, so I can use my perpendicular chord bisector theorem. So I set them equal to each other, and then I can subtract an x from both sides and then divide both sides by 10. So I'm left with x equals 7. I'm not done yet because I was told to find the measure of the entire arc. So I go ahead and plug that back in, and so to either side, it doesn't matter. So I picked one side, and I know that half of it is 77, and I was asked for the whole thing, so I can multiply that by 2, and I get 154 degrees. So now here's kind of a real-world problem that we're looking at. So I have 3 bushes that are arranged in this garden as shown. Where should you place a sprinkler so that it is the same distance from each bush? So the first thing I kind of want to do is draw them outside of the picture, right? So kind of draw and label them out here. Then the second thing I want to do is I want to draw the perpendicular bisectors, right? So perpendicular meaning the 90 degrees, bisector is cut in half. So I want to draw those perpendicular bisectors of AB and BC. So then using the perpendicular chord bisector converse, those lie on the diameter of the circle containing A, B, and C. So I know that these points both lie on diameters, so I know that those would be the center of the circle. So from there I can now go ahead and say that it's equidistant, so it's the same distance from all three. So the first step is to kind of draw them separately outside of the picture. Then I find my perpendicular bisectors and I find where those meet. So then once I've found where those meet, that tells me the center of my circle. So now here are the first couple questions that I want you to try and figure out. So now here's our next theorem. It's the equidistant chords theorem. So in the same circle or congruent circles, two chords are congruent, so the same length, if and only if they're equidistant from the center. So here, these two chords, A, B, and C, D, are congruent if FE equals EG, if the distance from the center is the same. So here's our first example for this one. So in the diagram, QR equals ST. So I'm told that information, and they both equal 16. Okay, so CU equals 2x, and again it's labeled for me, and CV equals 5x minus 9. So I want to find the radius of this circle C. So the first thing I know is CQ, right, is this part right here. That's one of my segments where one end point is on the circle and one is the center, so that would be my radius right there. Okay, so I can also see that making this radius makes a right triangle. So I have this is a leg and this is a leg, and I'm looking for the hypotenuse of my right triangle. So now I want to look at the properties of chords to help me get there. And here it's drawn again, so this is the radius that I'm looking for, is the hypotenuse of this right triangle. So the first thing I want to do is find CU, right? I have to find this length because that's going to help me. So because QR and ST are congruent, they're the same length, that means I know that these two pieces are the same length as well. So CU equals CV, right? Because now they're perpendicular, and so I know that they're the same length. So I can set those equal to each other. So once I set them equal to each other, I just substitute, and then I solve for x. So I get x all by itself. So now I found that x is 3, and I plug that back in, so I know that CU has the length of 6. So that's one leg of my right triangle. So now to find the other one, I know that the diameter, right, which is this segment here going through x, bisects this chord because I see this right angle, and I know that if I have a right angle, it's been bisected, so I can use the perpendicular chord bisector theorem. And I was told up above in the problem that it was 16, so I know that half of that would be 8. So now I know both side lengths of both legs of my right triangle, so I can use the Pythagorean theorem, and it is a Pythagorean triple, so I find that the radius is 10 units. If I didn't just see 6 and 8, and know that this was a Pythagorean triple, I could still use 6 squared plus 8 squared and then find the square root of that, which would give me 10 units. So now here's your last monitoring progress. See what you can do with these. See if you can take this information and find the radius, just like we did in that last example. So let's look at our learning target. Our big learning target for today was to use chords of circles to find lengths of arc measures. So we used different theorems that we know about chords to help us take information that we were given to find different lengths that we were not given. So now that we've gone through all of this information, now I want you to work on your homework for 10-3.